Hi, in this video I will talk about measurements in quantum computing. In the previous video, we looked into our first examples of quantum circuits. In quantum circuits, we saw that we can get multiple measurements of a quantum circuit. But if you want to obtain a final result, final state of a quantum circuit, we need to take multiple measurements. In the last example of the last video, we saw that we can do this, but with an error. And this error is inevitable. Since we have finite measurements, we will always have an error. But we can reduce this error by using some methods. The field that looks into this is quantum tomography. In this field, scientists are looking for ways to do this efficiently. In this video, we will see a very basic example of how we can extract the information of a quantum state. Here you see the very basic model that we use for extracting the quantum state, which is taking averages. We run the circuit for n times, then we take the average of the outcomes for over this n. In the end, we will get an error bar with respect to this number. So let's do this in Qiskit. We start by importing our objects from Qiskit. Then we define our quantum coin flipping circuit, which is a 1-qubit circuit that applies a Hadamard gate, then takes a measurement. Here the input is shots and we get the counts as a dictionary. Then we define an error function that calculates from this counts dictionary an error bar of 0 and an error bar for 1, which is subtracting the result from 0.5, which is the expected probability of both of these results. Then we take the maximum of the errors. Here we have multiple measurements numbers that we listed, and we will run our circuit for this number of times. When we run our circuit from 10 shots to 1 million, we get a plot like this. So on the x-axis we have number of measurements, and on the y-axis we have the errors. We see that as the number of measurements increases, the error bar gets smaller and smaller. Since we have finite sampling, even this plot will be different every time we run it. Here we see that the error bars are scaling with order 1 over square root of n, or we can say that errors are going with the power of -2. What is important here is when we want to extract the final quantum state, we need to decide on the number of measurements. You see that we can take this number and send it to infinity, and we would get infinitesimal error bars. But this would take quite long time and it will consume our resources. So we will decide, depending on our application, to choose this number of measurements and decide which is the best error and which is the best number of measurements for our application. You can find more details in the references and also Nielsen's book.